Hello, Professor and class. This is a single pilot operation final report presentation by Nicolas Novoa Medina. In this presentation, I will present first the problem and intent statements, research question and hypothesis, literature themes, the data collection and analysis plan, the results, conclusions, and recommendations. Problem statement and intent statement. At present, most air cargo transport operations in the United States are required to have two pilots on the flight deck according to Federal Aviation regulations. However, there is a push in the industry to adopt single pilot operations, the SPO, which makes it imperative to identify the piloting tasks that carry the heaviest workload and the highest potential for cognitive overload in order to automate them. The objective of this qualitative examination was to investigate the primary duties that impede pilot concentration with a specific focus on workload and task fulfillment. The aim of these undertakings was to identify taxing tasks and impose a significant burden on pilots, as opposed to other factors that affect their competence. Research question and hypothesis. When dual-engine aircraft, typically operated by two pilots, are now reduced to a single pilot operation, it becomes impossible to completely prevent mishaps and risks. That's my hypothesis. Research question. In terms of workload and safety, it is worth the risk of reducing the number of crew members in the cockpit? Here in literature themes, we're gonna see obstacles to SPO, piloting benefits from redundancy, and high workload periods. The first one, obstacles to SPO. Aviation prioritizes safety above all else, despite significant technological advancements. Reaching the level of human-machine interaction required to enable single-pilot environment is still decades away. The intricacies of human faculties such as sensing, assessing, reacting, adapting, and interacting are intricate and necessitate high levels of human-like simulation to achieve the safety benchmarks we currently enjoy with two pilots. Second, piloting benefits and redundancy. Having a backup systems and procedures in place ensures that in the event of a failure, there is a backup plan. This redundancy can be implemented in various ways, such as having multiple engines, backup instruments, and emergency protocols. Essentially, redundancy provides an extra layer of protection for pilots and passengers alike. The requirement for a two-person crew mandated by the current federal law is not the only factor that contributes to the disapproval of single-pilot operations. The aviation and aerospace industries rely heavily on a system of redundancy. Unless a highly advanced automation system replaces the pilot, the sole pilot is responsible for executing all the necessary procedures and responsibilities required to ensure a safe flight. This single-handed operation is not a feasible option and leads to a decrease in performance since task allocation becomes an issue. Finally, High workload periods. Each phase of flight presents its own unique challenges to the flight crew. A recent study was conducted to investigate how the required crew size, specifically two crew operations (TCO), affects the pilot's workload during each phase of the flight and its correlation to SPO. Anomalies such as system malfunctions, adverse weather, turbulence, and in-flight emergencies can be more effectively handled with a two-person crew is present due to the ability to split tasks between individuals. Data collection and analysis plan. When examining a varying levels of impact in the area of pilot workload within single pilot operations, independent researchers utilize numerical data to create a qualitative argument. To create this quantitative research design, the data used in the design is a compilation of published reports from scholarly articles in journals, the Airline Pilot Association, ALPA, and the National Aeronautics and Space Administration, the NASA. Careful consideration was given to all relevant data and research topics pertaining to the matter. The single pilot operation is expected to provide a common solution and ideas with results. The ideas arising from single pilot operations can potentially be alleviated with the aid of this solution. Results. In this research, the themes mentioned are centered around two primary objectives: warranting the safety of flights and introducing only high-fidelity single-pilot operations assistive automation technologies. These two overarching thematic patterns present in each of the three themes advocates for a cautious approach to the early implementation of single-pilot operation enabling technologies. The themes recognize and there is a plethora of technology available that can automate various operations, but they also acknowledge that introducing such technology too early can lead to redundancy, high fidelity, and FA issues. The implementation of single pilot operation has proven to be profitable move for many companies, demonstrating the success and capability of a lone pilot to operate a plane with the help of intelligence systems and autopilot functions. Conclusions and recommendations. The aim of this study was to investigate whether the airline sector can safely establish automation technologies, protocols, and training to mimic a two-pilot environment in a single-pilot operation environment, and whether it is calculated risk worth taking. Even though the technology to introduce single-pilot operation exists, there is still uncertainty surrounding the safety element and high fidelity elements. Thus, the airline industry cannot eliminate the need for two pilots in passenger operations and rely solely on human-machine interaction. It is essential to maintain optimal safety standards while simultaneously troubleshooting and integrating innovative technologies. These technologies have the potential to elevate the industry's range of services and deliverables to new heights. With over 88% of aviation accidents being attributed to human error according to the NTSB, the future of aviation and machine control lies heavily in automation. In the aviation industry, the utilization of machines and artificial intelligence AI, is the optimal approach to minimize risks and enhance safety. Here, some references I use for my presentation. Thank you for watching.